I think I do now, very slightly. Hello? That would be helpful.
See what's going on.
Oh, perfect. Okay. I guess this is take 3. It'll get better next time, I promise. Okay. Can the Zoom people hear me now?
Yeah, we can hear you. Yeah, we can hear you.
I'm just gonna take that as a yes. Yeah, okay. So this is the Spoken Digit Recognition Project, which is a project in which we'll have a bunch of little audio files that someone could say a digit in each audio file, and then we'll be able to recognize what they said. And so this first presentation will be first in 2 parts. It'll be how to use Git and GitHub, which is an important skill to have, and we'll probably use it on this project. And the second part is where I will break down the different steps of how to actually go about this project to make it more manageable and approachable. Yeah. So these are the 3 steps, which I'll go into more detail later, but basically there's 3 of them. The first step would be to just handle the data, the second step would be to make a model, and the third would be, I guess, in a simple way of saying, make the model better. But first, we'll talk about the GitHub portion. These are the 5 important parts of using Git. Committing, which is just saving your progress. Remotes, which is like connecting to the GitHub website or some other server where you want to save your progress and collaborate with other people. And pulling, just how you actually share what you've committed with other people. And branching is if you want to make new features. And merging is complicated and involves combining 2 different branches to make one newer one. So the very first command is Can you say that again? Oh, okay. Git push and git pull is if you have something committed, then you push it to github.com or some other server. Usually it would just be GitHub, so that other people can access what you committed earlier. And pulling is if someone else pushes to GitHub and then you want to see what they've done and like save it on your own computer and all that. So the very first command you will run is git init, which is if you have a folder where you are going to start your project, you would type this out. And it would basically just like set up the whole versioning stuff. And that's like the start. And then after you make changes, it'll all be recorded and logged, and you can even revert changes once you do this. Actually, so the first, after you've actually made some changes, one of the first commands you'll actually run is git commit. And it's, like I said before, it's just how you save your changes. And then, like say, if anyone, whoever is following along, if you just add in like a text file that just has something in it in the folder that you ran git init, and then do git commit, you'll see something that looks a little bit like this. And it'll tell you that nothing's actually going to be saved until you actually add these files to Git. And you would do that by typing in git add and then minus a capital like I have there. You could, if you really wanted to, type git add and then the name of each file you want individually. But there's no real good reason to do that because that just takes a lot longer. So that would be the most efficient way to do it. And then the next part of doing that, after you've added all your files to Git and then you commit them, you'll need to put in a message saying, like, what is this commit you're doing? It's helpful for the other people you're working with and also helpful for you if you need to, say, go back and see what you did in the past. And if you do revert, then you know exactly what happened on that change. And in my case, because I use the terminal, it'll show up like this, but for most of you, it'll show up as like Notepad or something. It's just you type in the message, then you save it, and that's it'll take care of the rest automatically. Okay, the next part is Git remote. So if you do want to follow along, then you'll have to actually go to github.com and like set up a repository, which I can do right now as a demonstration. Goodness gracious. Um, not that. Okay, so this is my GitHub and I can make a new repository, which is right up with everything. And that would be basically how you create the repository you need. And actually, when you do that, it gives you these neat little instructions to tell you how to actually set it up. Okay, so for those of you who are following along and after you've done the commit and all that, the next thing you would do is this command here, which is git remote add origin. And then when you have your GitHub repository, you'll have a link to it. In my case, it would be this. And then you would simply just push it like that, following those same instructions that they nicely provided. Also, just a quick question, who is actually trying to follow along? Is everything good? Mhm.
Then I connect my the
Yes.
and what was the second last time you use Git branch and
Oh, this is because when you start the Git repository on your computer, by default, it names the branch master. But on the website, it expects things to be named main. There's a lot to explain there, but basically to get around it, you just name the one you have on your computer main, and that solves that problem. Yeah. Is everyone ready to move on, or should I wait? So then after you set up your remote and you've started your repository, the next thing you could do is push and pull. You can't do pulling because you aren't really working with anybody else who would push something that you could pull. But for now, you could try push after you've committed and you've ran the command from the previous slide. Then you should see on the GitHub website your file is starting to appear after a couple minutes. And of course, remember to commit all of your changes before you push, otherwise it won't actually send anything useful there.
commit and push.
Commit, basically in the folder that you've been working on your project, it saves it there, but it doesn't, no one else can see that. So pushing puts it onto the website so other people can see it. And would it be useful if I did all of that in a terminal like right now, like live? Would that be useful? Yes? Okay. Okay. So here's a little command window, and if we just make a folder, this part's not important because you would normally just do this in Windows Explorer. Um, okay, so this is the folder in which I'll run Git init, which is the first command we went over, and I'll just make a file here that doesn't really have anything in it. And so if you look in this folder, there's now a file called blah, and we can put something in it. And just save that. And don't worry about the fact that I made the file and like edit it in a command line. You can always do it in any way you'd like. And so the next part we talked about would be the git commit. And like on the presentation, it tells you that the files in that folder, in this case, there's only one, it isn't actually being tracked or saved. So you would have to do git add -a to add all of the files. Again, in this case, there's just one. And then if you try to git commit again, it now puts that, oops, spell that wrong. It now tells you that there is a file that can be committed, and you can just type in a message. And then save that. Again, it would probably be Notepad for most of you. And so now when you run git commit, it tells you there's nothing left to commit because that file that we just made and edited, it's been saved, it's been committed, and it's all good. And then the second part, which is the pushing and pulling, which we're on now. I would have to do git remote add origin and the URL of the one I just made. Which would be this. Okay, I guess that command doesn't actually have any output. Okay, and then we also have to rename the branch. And now we can do the final step of setting up the connection to the website by running the final command, which is git push a new origin name. And now this last line is important where it says the branch main, which is your branch main on your computer, will now track the main from origin, which we previously set as the URL to the repository made on github.com. And so now if we go to the GitHub website and see this and just refresh the page, we see the file and whatever I typed in earlier. And actually, there is a way to test the pulling if you go onto the website and then just edit whatever file you have manually, like this. And just save it here, you can pull it later, and you should probably have a message. Okay. So now if we go back to our version and look at this file, it's whatever we originally put in. So to get what we put in on github.com, we can do git pull. And as you can see, it's updating based on whatever is on the website. Oh, this chat stuff. Echo, I did not know this. So now if we look at the file that we have, it has that change that we originally put in the website. So that would be basically how you collaborate with other people. They would put stuff onto the website and you could download it. So the next part of Git. So I'll just check again. Is everyone following along? Yes, no. Should I go over anything again? Okay. Okay. The next bit is branches, which can get messy, but we can try. Basically, if you are working on, say, some kind of big project and you want to try like messing around with creating a new feature or something, you wouldn't want to do that directly on the same version that everyone else is working on. So what you do is just like make a branch with any name you'd like. And that just creates a branch. And you can see this if you type in git. If you list all the branches, you can see there's main and it's starred, meaning we're on it right now. And there's also the branch called new name, which we are not on, but we can switch to it. So if we do git checkout, which is how you basically just open up all of the changes from a certain branch. In this case, it wouldn't do anything because both of these branches are exactly the same. But now if we do git branch -l, it now shows that we're on this branch and we can make changes on this branch like this. And then we can just commit that. Okay, and now if we look at that file, it has all three of these lines in it. But then if we choose to switch to the original branch, which we did not have this change on. Then if we do, that change isn't there because we never actually committed that change onto this branch. So now you have two branches that are running in parallel and have completely different code or data on them. And so that actually brings us to the next part, which is to merge branches. But one thing I do want to note about switching branches is that on really big projects, especially like Unity games and stuff, when you switch branches, it can take a long time to like rewrite all those files because like if you have a big thing on one branch that doesn't exist in another, that means when you switch to it, you have to like create those files from scratch again. You just have to wait for it to do its thing and eventually it does. So the next bit would be to merge these two branches that we now have. So I believe that's just a simple git merge. Sorry. So basically we just merged branch new name into branch main, if that order is correct. And so now if we look at we're still on branch main, but because we merged, that file we've been playing with should have all three changes in it. So the way you use this in an actual project is if you finished working on that little side feature you were using or trying to make, then you'd want to share with everyone else. So you just merge it into the main branch. And if everything works well, all of those changes from that branch will be copied over and then you could just move forward like normal. So I think that basically covers all of the Git stuff. Is everyone okay with that? Yes? Okay. So this is the fun part, which is exactly how this project works. So basically we'll have a lot of audio files, which are these WAV. It's like just raw audio. There's not much to it. So because of how machine learning works, it has to be done using just numbers, and they have to usually be in the form of tensors or matrices, which are basically just like structured grids that can be just one-dimensional or two-dimensional or three or however many dimensions you want. For this project, they will be two-dimensional because if you think about say like how like what a waveform might look like, it's basically like at time n, or if we start at time 0 and then like go all the way up to time n, then it's like a column, and in each part of the column it's like what is the sorry, upwards is frequency, and so you'd be like, it'd be like a value, like how loud is it at that frequency at this point in time? And it would just be a data structure looks like that, stretched across for however many seconds the audio is. When we actually open up the audio files in the next workshop lesson, that'll be much more clear than me just describing it by words. But once you see that, it really is intuitive. And so that's how we would, put those into the model so that the model could learn from it. And more specifically, the library we'll be using is librosa, which is on Python. And you don't have to install it now, but you could if you wanted to. Yeah, and the important part of that is that it lets us see these audio files as matrices of numbers, which is exactly what we need. There's a lot of math to it, which I'm really not qualified to explain to any of you. But basically, it's just like if you have a waveform, how do you decompose it into smaller functions, smaller, simpler functions specifically, and then you can write those equations out kind of like that. So the next step after we've learned how to pre-process the data and actually load it into numbers is to actually pipe it into our machine learning model. In this case, we'll be using TensorFlow, which lets us make regular neural networks. It lets us make neural networks that kind of learn across a series of time, like a recurrent neural network, that would be the actual name. Or we could use convolutional neural networks, which are really good at handling like 2 or 3 dimensional data. In this case, we do have 2-dimensional data. So that'll probably be what we use. The reason we're using something called TensorFlow dataset is because for big projects like this, you can't actually load all of the audio files all at once because that takes up too much memory. So the trick to deal with that is to load each file one by one as we're processing them in the model. The dataset API in TensorFlow is really helpful for this because it basically creates this object that knows where to look for the files. And each time the object is called to retrieve the next file, it on the spot loads it from the hard drive, and then it'll run through the libraries we have listed here, and then it'll give it back to the model, and the model wouldn't know where it came from. It's just being fed these matrices, which is exactly what we need. And that would be the end of it. Basically, the last 2 slides are what we'll be going over in detail and actually implementing in the next workshop. Yes. Yes. Any other questions? I don't think we do. Do we have like a club-wide GitHub? Okay. That's possible, yes. Yeah, I agree. That's probably better because it's more popular. Yeah. Yeah, I don't see why not.
All of our future workshops are going to be 6 to 7. I just think it was better for this class scheduling, unfortunately, viewers. Next week we have our first mobile meeting. If you guys applied for mobile projects and have questions, I'll say that a little bit later. You guys should be getting texts about Snowball today, actually. Some of you probably just got them. But yeah, so next workshop is not next week, but the week after that.
Also, pretty sure the next workshop will have less technical problems. Like, pretty sure.